Okay, this is module 1. As you can tell, I've already started the module and entered my student number. Um, so this is problem number 1. The text, as far as this module goes, isn't important because regardless of what the problem says, all you really need to do is take the measures and construct a frequency histogram, as it says right here. So the first question you're asked about this data set is the measurement precision of the data. So as you can tell, the number of digits to the right of the decimal point is equal to 1, so the measurement precision is 1. Okay, is there an outlier in the data set? Because these numbers are ranked, the outlier will be either at the end, so it'll be a number that's larger than usual, or in the beginning it'll be a number that's smaller than usual. You'll notice here minus 33.4 is an outlier, so the answer to that question is yes. Enter the numerical value of the outlier, it's minus 33.4. Okay, enter the range of measures. The range of measures is equal to the smallest number in the data set that's not an outlier, or the largest number, minus the largest number that's not an outlier minus the smallest number that's not an outlier. So in this case, I'm just using, this is a program in Mac that's similar to Excel. I just want to use it so people can see what I'm doing. So it's 11.7, so plus 7.4. Okay, so the range is 19.1. Enter the boundary of the lowest category. The boundary of the lowest category is the smallest measure that's not an outlier minus half the measurement precision. So the smallest number that's not an outlier is minus 7.4. Okay, you take that number and subtract half the measurement precision from it. So this is 7.4 minus half times the measurement precision. So there's a formula you can use. It's 10 minus measurement precision. I'm not sure if that's still true, or you can just look and say, okay, well, what's the smallest measured possible difference between the data points given whatever instrument was used to measure these? So in this case it would be 0.1. That's as precise a measurement that is possible in this case. For measurement precision of 1, it's always 0.1. So it's so this is the computation. So the boundary of the lowest category is minus 7.45. Enter the category width. Now the category width is simply the range, which is 19.1 in this case, divided by the number of required categories, in this case 8. And you have to round this off to the measurement precision, so this will be 2.4. Now the thing about the category width is that you have to make sure it's large enough so that the largest number in your data set will still fall within the range of your last category. So we know that to construct the categories, we start off with the lowest category boundary and keep adding the category width to that number. So to get the upper boundary of the highest category, which is what I need to do to make sure my width is a large enough number, so I add 8 times the category width to the lowest boundary, because 8 is the number of categories, and so for now the category width is 2.4. I'm just gonna, okay, so 11.75. So this is higher than the highest number in my data set, so that will suffice as the category width. So 2.4 is fine. Specify the category boundaries. Now if that wasn't, if 2.4 wasn't enough, what I would have to do is increase this number, the width, or 2.4, by the measurement precision until the upper category boundary was larger than my largest number, so I would have to increase this to 2.5, and then if that wasn't enough, to 2.6 until I had a large enough width. But anyhow, it was enough in this case. So now you have to enter the upper boundaries into the spaces here. So you start out but with the first category, so the upper boundary of the first category is minus 7.45 plus 2.4. It's minus 5.05. And then to get the next boundary, you add 2.4 to minus 5.05. So it's minus 2.65. And you keep doing this until you've filled all the category values. So this is minus, okay. Feel free to skip ahead at this point. I just have to do these computations. So 11.75 is the highest number. Okay, so it says you're right. That's great. Now the next thing you have to do is count the number of measurements that fall within each category. So how many numbers are between minus 7.45 all the way up to minus 5.05? So that would be 1, 2, 3, 4, 5, 6, 7, and that's it. So you'd enter 7 in here, and then you'd move on. A good way to check your work, obviously, add all the numbers up. It should be equal to the total number of specified measurements, not including an outlier. So I would have to end up with 73, or 72, sorry. Okay, now I'm not going to do this. After this, the program will automatically plot a histogram for you. It may ask you to do the same thing for another data set, or compute the cumulative frequency histogram, and that's not very difficult at all. So I'm going to stop here.